Hi everyone, my name is Anedu Dobong and I'm a regional lead for developer community programs at Google. Thank you for joining us today and welcome to Between the Brackets. Feel free to introduce yourselves in the chat and we'd love to know where you're joining from. While you do that, I'd like to kick off with a brief introduction about Between the Brackets. Between the Brackets is a monthly web series where we host experts and Googlers to talk about niche topics around Google products and technologies. This could cover web, Flutter, Android, Firebase, cloud, machine learning, and these are themes we've covered all through the year. We're thrilled for you to join us today, and we hope you enjoy the show. A little bit of housekeeping for today. As with all Google events, this is a great guideline I'd like to remind you of. Be excellent to each other. Please follow our community guidelines. We know you're interacting online, but please keep comments civil, to the point, and related to the topic of today's conversation. Please add your questions to the chat. Be mindful of others as well. If others have asked questions, you're free to plus those questions, but not necessarily ask them again. We're here to help you with your questions. If you have any concerns throughout today's shows, you can share that with us at btb-team@google.com. Today's episode of Between the Brackets will cover current trends in artificial intelligence and its real-world impact. On the show today, we have Jerry and Margaret. I will briefly introduce Jerry, who's a Google developer expert in machine learning and the author of numerous courses on machine learning. Jerry has worked for numerous clients in the technology field in various areas such as biotech, finance, scientific processes, and product development. Margaret is also a Google developer expert for machine learning and an ML engineer working on applying artificial intelligence and machine learning to real-world applications from art and design, climate change, to safety and society. All right, let's get started. Let's bring Jerry and Margaret on stage.
Hey everyone, how's it going? Let's get our slide deck going here, and I hope you're having a good day. So this is a little bit about me. As Adit said, I am a MLGDE, and I'm also an author of technical documentation, or technical courses, primarily for a company called Pluralsight. So if you're familiar with them, you can find a lot of my courses up there. When I'm not doing that, I'm usually messing around with something in machine learning and AI. And specifically these days, I've been very interested in something called TinyML, which is really, really interesting to put all our big models onto these small devices. And that's enough about me. I'll turn it over to Margaret and let her introduce herself.
Thanks, Jerry. I'm Margaret, and I'm could you move the slide to the next one, please? Okay, I'm Margaret. I'm a machine learning engineer and artist. I love painting and drawing in my spare time. Also, this past year, I spent a lot of time on 3D fashion design. I have been a Google developer expert for machine learning since 2018. I'm also a community leader for GTG Seattle and Seattle Data Analytics and Machine Learning. So today, Jerry and I are super excited to be here to discuss two very important trends in AI that have significant impact on our lives. The first topic is on-device machine learning, and then the second topic is generative art and design. So when we say on-device machine learning, we are mostly referring to running inference on small devices. So, even though we call it on-device machine learning, there's still very limited model training happening on device. An example of these devices include phones, tablets, Raspberry Pi, FPGA, Corel TPU, and real tiny devices such as microcontrollers. And for on-device machine learning, we usually could use dedicated hardware or located in diverse locations on the edge, or it could be a brain of a machine or other tools, or based on small, low-powered micro processors. So now I'm going to hand it to Jerry to discuss some of the computing resources of these edge devices.
Thanks, Margaret. So, you're probably used to seeing computers more like in this left-hand column. You have you're either using a server in the cloud or you're using a laptop on your desk, or maybe, you have a gaming PC or something like that. So as you go down these columns, you can see the differences between what we're talking about when we say we're talking about a server or perhaps a phone or a tiny device. Just look at the memory one, for example. As you can see, the server or even a laptop, I don't know if you have a 228 gigs on your laptop. If you do, you probably have a very nice, expensive laptop, but most of us don't. But you can see these, are just orders of magnitude beyond what you would have potentially on a tiny device down there to 64 gigabytes or 0.00064 gigabytes, so 64K. Similarly, situation with the storage. We just on these small devices that we're talking about, you don't have a lot of storage out there. Computing, you can look at the computing thing. So you may be thinking, how can you why would you even want to do machine learning on one of these? Well, then take a look at the costs row as we go across there. These other devices are very expensive, but we're talking about devices that cost just a few dollars to buy in single quantities. Now, if you're building something, think you're building a smart whatever. We're going to talk about something that makes burgers in a while. If you were building one of those, you would want to make a lot of those and sell them to every McDonald's. So you're going to be making tens of thousands of them. And you want a quantity discount. So you can get those perhaps for 50 cents. You can put in artificial intelligence into your hamburger making machine. The other advantage is, look at the size. The size in one of these devices is just a few centimeters. They're very, very small. I mean, it literally will fit on your fingertip of your pinky. And then there's power usage. Power usage is just dramatically lower. So you're bringing machine learning, AI, down to a very, very small platform. This low power usage means it can be out in a field, perhaps looking at insects going by and figuring which ones are good and bad, and just be charged with a little battery and a solar panel day after day, and telling farmers perhaps, is there a bad bug out there that's going to eat my crops? Now, of course, we have to develop the code and the models to work with that. We can use tools like Linux in our server environment and all of the appropriate libraries and things that come with a full-blown Linux environment. When we look at moving to the phone, we don't necessarily have those. If you haven't done phone development before, you do that typically on that big computer and then push them to the phone. And for there, we can use TensorFlow, or the one that is targeted for phones is TensorFlow Lite. It runs in small versions of TensorFlow because these are limited machines in terms of performance and memory. Similarly, it's even worse, to be real honest, when you get to these very, very tiny devices. And so they've created a special version of TensorFlow Lite called TensorFlow Micro, which really, really compresses down the models and deals with all sorts of nasty situations like, well, we have floating point numbers and we need to fit them into 8-bit space and integer space. How do we do that? It takes care of you for that. And then we also have development environments based on that. Now, the one question I always get whenever I talk about this is, what about the Raspberry? Let me go back. What about the Raspberry Pi? I have one of those. And if you look at the Raspberry Pi in comparison to a common tiny chip, you can see the difference even there stands out. The Raspberry Pi has quite a bit of memory. It has storage. It has some computing. But as you've noticed, the difference isn't that much in the computing. So you're getting a lot of the similar computing in these very, very small chips. Cost is obviously less. And a Raspberry Pi kind of fits in your hand versus a chip that you can just put into another circuit somewhere out there. And importantly, once again, as I mentioned, is power usage. Power usage of these chips that go into these tiny devices is very, very low. So again, they can be battery powered, or if you have to hook them into an existing system, you don't have to stick a power supply into it or something like that, or be worried about blowing up the existing power supply because you added intelligence to it. Likewise, interestingly, this is no operating system, running. You're putting it hardcore instructions on the microprocessor or into a storage that the microprocessor can access. And once again, we have the TF Lite and TF Lite for micro. Let's see here. So let's talk about some use cases for these devices. Well, you can read these as easy as I can, but I think the bottom line is the first sentence, where we're bringing the power of machine learning to non-traditional settings like factory floors, farm fields I mentioned with that bug detector and things like that. One I saw did bug detection, and it was determining whether this is a nice bug or it's a pest. And if it's a pest, it would fire up a very low power transmitter and send a text message to the farmer saying, hey, out here in field XYZ, we have a potential problem, and you might want to come out and inspect it and determine what sort of corrective course of action, be that, spraying it or picking the crop early or whatever it is. A lot of fields get improved by this, and you can read these, manufacturing, transportation, safety, entertainment, right? Gaming is really important. And one that is really interesting to me is medical devices. I have some background in the medical device industry, and one of the things we always were concerned with was we just didn't have the computing power or the brains to do a lot of things we wanted to, like build an intelligent hearing aid or devices that monitor and treat diseases. But one of the reasons I wanted to do this talk with Margaret was because she kind of works in this area. So Margaret, maybe you could give us a little bit about your experience on what you've worked with in that area.
Yeah, sure. Jerry, I have been working on device machine learning since 2016, for a while. I've worked on smart camera apps where we use machine learning to detect colors, text, or objects for visually impaired people. I've also worked on apps that use drones to detect sharks on beaches for public safety. And then I have also worked on a number of open source projects with TensorFlow Lite. For those of you who don't know what TensorFlow Lite is, it's like a framework to help you. You can optimize your models for deploying to these small devices. And one example that I have worked on is turning a selfie into a anime, or turning a selfie into a cartoon image. And then another Android app I worked on in collaboration with other MLGDs was to segment a person from the background and then apply style transfer to the background image. Very much like when you use a video conference service such as Google Meet or Zoom or Teams, when you apply a special effects of your background, right? You have two models. One is segmentation and another one is a style transfer. I don't have it on the slide, but I also want to mention I created a repo called the Awesome TensorFlow Lite repo with a list of TensorFlow Lite sample apps, end-to-end tutorials, books, and blog posts and video courses. You can check it out. You can just Google Awesome TensorFlow Lite. You will find it, and check it out if you wish to learn more about TF Lite. So here's the workflow for on-device machine learning. They're typically very similar, right? Because for on-device machine learning, hardware is actually very important when you define the project. And because we're working on, limited resources here on the target hardware and operating system. And we also will gather, so that's the first step, is to define the project and figure out what hardware you're using. And then the second step is to gather the data. It could be some sensor data, which Jerry is going to do a demo and show you later on. It could be images, it could be audio, and then you train your model. You could train from scratch, or you can use some of these pre-trained model from TensorFlow Hub, and then you can use transfer learning on it. And then once you train the model, you have a model. We need to optimize the model. Typically, when we do on-device machine learning, we want the model to be small, right? Whether it's on the phone or Raspberry Pi or FPGA, you don't want the model to take up a whole lot of space. And you also want the model to be really fast, right? Much faster than if you were to run a model in the cloud or on a computer. And so optimization is a very important part of on-device machine learning. And if you're using TensorFlow Lite and all of these optimization, quantization, pruning, etc., you can use the TensorFlow model optimization toolkit. And then you deploy the model to the target system, right? So on this host system, you train or perhaps you train in the cloud. Host system, you optimize, and then you deploy that optimized model to the target system, which is the device we're talking about, the small device. And then throughout this whole process, we do a lot of testing. You test your model after it's trained. You test the model after it's optimized, just to make sure it is still performing well, once you make it smaller and faster. And then you test it again after you deploy the model to target devices. So now that I've talked about the workflow for on-device machine learning, I'm going to turn it to Jerry to give us a demo of running a machine learning model on Arduino.
Okay, thanks, Margaret. Let me get this set up here. I just realized.
Jerry, don't forget your slide. There's a slide.
Yeah.
If you flip forward.
Oh, thank you.
No, go back one more.
Back one?
Yeah. So.
Okay, sorry.
Yeah, there we go.
Sorry about that, guys. So I'm going to do a demo of a machine learning model that I trained on a little Arduino. I'll show you just how small these things are too. Pay attention to that. The goal of this is to detect anomalous motion. I kind of led into this before, but essentially, if you can see me here, if you look at my picture, we're going to flip like a burger, and we're going to chop things. So imagine we were building an arm, a robotic arm that had these two motions in it, and we had trained it to flip burgers nicely and to chop onions, because nobody likes to have chop onions, or tomatoes or lettuce or whatever was needed in that part of the process. So we want to train it to do that, and also we want to train it to detect anomalies, because as those machines, robots are running, over time, they're going to develop faults. The arm isn't going to come down smoothly. It's going to drag because, food particles got in it. It got rusted. The robotic components wore out, what have you not. The flipping won't be smooth. It'll maybe bounce up and down and things like that. But we still want it to know primarily it does two things. It chops and it flips. But if it's starting to not do those things well, we want to be able to detect that so that we can get somebody out there to fix it before it, completely dies in our fast food restaurant or whatever. We have to take that station down, perhaps, go back to doing it manually. Heaven forbid we do that. But, or have to have the tech out. And if you've ever had anybody come to your house these days to have anybody fix anything or took your car in to get it serviced, you could know service techs are way backed up. So you really want to be able to detect this early on and deal with it. Okay, I'm going to go into this with something called Edge Impulse. Edge Impulse is a framework, and let me get it, launch it over here in a window. Let me just do it in this window here. Sorry, guys. Live demo, taking your life in your hands. No. Let's just exit out of here and bring it up here. Impulse. And let's log in. Okay. So this is a tool that is actually built on TensorFlow Lite and TensorFlow Lite for microcontroller. It just puts a nice interface on top of it. Nothing that they're doing you couldn't do just directly yourself. So they have this nice dashboard, and you can see this is my project here. I'm going to, coming along this left-hand edge, they have devices you can put in. So I'm going to show you this on an Arduino, but you could do it on a different processor too. Then all machine learning learns from data. That's kind of 101, the first thing you learn in machine learning. So you have to have some data sources. So this gives you an option if you want to, you know, taking a file and putting it in, and it deals with all the kind of messing with the data and things like that for you. Then you can acquire training data. We're going to do some, we previously did some flipping and I did some chopping, and I did use this to get that. Then I'm going to create a model with that. They call it an impulse because it's a model with a lot of other features. I did that earlier, and then we're going to do some analysis. So what I'll show you now is we're going to go ahead and kind of come down here and do a little live classification with my pre-trained model. So let's run that. And I'm going to first reset my device. I'm going to connect it up. This is a little Arduino Nano. This is about a $20 thing. I'm putting it in front of my face, so hopefully you guys can see this. And you see a lot of devices on here, but most of these are just sensors. There's like a humidity sensor, a GPS, all sorts of things. The actual chips, if you can kind of see those little black dots here in the center, that's the size, that's what a tiny ML processor is. And so now I guess you can see why in something that small, we only have 64K of RAM in it and maybe 128K of storage for the actual whatever you're going to run. So I'm going to push this little button, which is going to reset it. You hear that? We're going to now connect it, and there it is there. And here in a moment, yep, it went out and found the device ID you can see on the screen. And it's going to use the built-in accelerometer. It's going to measure in X, Y, and Z coordinates what's going on here. We're going to pick it up for 9 seconds, and it's going to pick up about 62.5 samples per second. Okay? So once again, let's just see what the normal operation is here. So it says waiting to start, and if you watch on the camera, you can see I'm moving my hand up and down, up and down. I'm chopping, right? I'm chopping. And so we chop, 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 chop. And it's now going to classify those. And hopefully it'll say I'm chopping. Yeah, and you can see it says of all those, 56 of those were chopping. It thought a few of them were flipping and it thought some were anomalies. And that was just because I was kind of messing with the cord. If you look in this upper right-hand column, though, you can see the accelerometers. Here's the X one is in the orange. The green one is the Y-axis, and the Z-axis or Z-axis is in the blue. And this is representing the chopping motion. You can see when my hand went up and down, kind of in the green. And then I kind of moved it around because I was moving left to right. But in a machine, I suspect this would be, it would be held, a robotic arm would not move left to right very much at all. So you'd see very little of this blue and the orange stuff. It would mostly just be up and down, up and down. And here's the time across the bottom. So you can see this is going over time, and there's a window. It classified them, and down here in this lower area here, you can see where it classified them. And here's your chop ones, or the green ones, and the yellow ones were flip motion. A lot of the motion it gets confused with as you move. So it's kind of filtered out, and over here on this side, when it figured out they were all chops. Okay, so that's good. So that's good normal operation. Now let's go back again and acquire some more data and see what happens when things are not quite so good. Okay, let's do some live classification again. And I'm going to reset the device. Button. Okay, and you saw that thing just blipped off and on my screen. It's coming back. Once again, we've hooked up to the device. We're going to use the accelerometer. We're going to pick up 9 seconds, and we're going to pick it up at about 62.5 samples per second. Okay, so we're chopping, but this time, if you watch my hand, it's not going so well, right? My hand is having problems, and I'm not that smooth chopping mechanism, but it's just looking kind of goofy. Things are not good. Okay, so let's see what it thought of that. We have it, it's classifying. And yeah, if we come over here, if you look at the center area here, it said, okay, 7 of those I figured out was a chop. Some I thought was maybe a flip, probably because there's a sideways motion. And they were anomalous. And we had some I just couldn't figure out what they were. And if we look down here, we can see these here. Let's get into this good section here. Yeah, I thought it was a chop or maybe a flip and things like this. But what you see is this rise of what we call the anomaly column. This is, if you want to call anomaly uncertainty, like I didn't know what was going on, you can figure out, you can use that column for that. So what's happened is it's detected this anomaly. Now, you could write your code on this device such that if the anomalies come up beyond a certain level, I'm going to turn on a light. Maybe you have a green light when it's, chopping or flipping just fine. And you have a red light when it's not having such a good day, and there's something wrong. Because, it's one thing to maybe, chop the lettuce a little off, but it's another thing, that's probably going to fix itself. So you want to get somebody in there, have them fix it before your process goes down and you have to shut down that line, whatever it is, your burger assembly line or what have you not. So you just want to do that and detect these anomalies early on. Does that make sense? Do we have any questions about that process? Okay, I'll move on, and if you come up with anything, just put it in the comments and I'm sure they'll tell me about it. Okay, back to this and back to the slides. And I think, let's see here. Yeah.
Thank you, Jerry, for the.
That's it on our on-device stuff. So, Margaret, you want to summarize for us?
Yeah, sure. Thanks for the great demo using Imagen on Arduino.
Let me share this slide again. I'm sorry.
I don't think we need to share this slide on the summary. Okay. I'll just talk through it. Okay. So in summary, machine learning makes devices and processes smarter. We can use our previous TensorFlow expertise and tools to create models. And I also highly encourage you to read this blog that written by Pete Warden called Why the Future of Machine Learning is Tiny, meaning, on-device machine learning has a really huge impact on our lives. And I would expect deploying to these edge devices are going to get easier, and we're going to see even more application use cases using machine learning models on the edge. And now we are going to transition to discuss our second important trend topic, which is generative art and design. Jared, could you share the screen, please? Or
yes,
Madhusha, please add the.
Yeah, let me start this. I think I killed the presentation again, so let's.
Great, thanks. So art and design is a very broad concept, including many topics. And art is not just images, it can be music or videos. And design could be product design, fashion design, graphics design, or UI UX design, and so on. So today, in the discussion with Jerry, we'll touch on some of these topics. And next slide, please. So, talk about generative art and design. We want to talk about what are generative models, right? Ian Goodfellow said, generative models is to take a machine, observe many samples from a distribution, and generate more samples from that same distribution. There are many different types of generative models, GANs, which have been really popular for since 2014, the generative adversarial networks. And then we also have variational autoencoder and flow-based models and diffusion models, which is used in DALL-E and Imagen and the stable diffusion. And you probably heard a lot about it since the stable diffusions are releasing in August. Next slide, please.
Oh,
so I like to draw and paint. I also like to create sketch notes when I study and read paper, etc. So here's my sketch notes on some of the GAN variants and diffusion models. Since Ian Goodfellow wrote the original GANs paper in 2014, there have been so many GAN variants, and they tend to build upon each other, either to solve a particular training issue or to create new GAN architecture for finer control or of the GAN model or better images. So I included a couple of these GAN variants with major breakthrough that provide the foundation for the GAN advances. And as you can see in blue, these are also the diffusion models or language models that I have included here. You see OpenAI's GPT-123, DALL-E, DALL-E 1, 2, Clip, and Google AI's Imagen. And all of these have made significant impact in the generative space recently. And of course, we hear a lot about stable diffusion in the past few months. I put both GANs and diffusion models here. Let's not discount, now that diffusion models are popular, let's forget about the GANs. I think it's really important to understand the history and understand how all of these models work. Next slide, please. So how do diffusion models work? Diffusion model have gained popularity in recent years or months, as I mentioned earlier. This is how they work. There's like a forward image diffusion path is gradually adding Gaussian noise to training data. And then there's like a reverse generative reverse denoising process. And that's when the model learn how to reverse the process to actually generate images from noise. So now, next slide, please. Jerry, if you could, let's take a look to visualize what that reverse denoise process actually looks like.
Oop. What happened here? Sorry, guys.
I think you just click on the image. Yeah, click on that link. Sometimes clicking the link may not work when you're in presenter mode, so you can give it a try, see if that works.
Oh, there we go.
Okay, there we go.
I wanted to do this.
Yeah, thank you. So this is the I talk about the forward path and then the reverse path. Right? This is actually reversing, going from a denoise process, going from noise to actual images that get generated. Great. Thank you. And now I am going to turn it to Jerry, who's going to look at, I talk about the diffusion model, how it works on high level and to visualize the process. And Jerry is going to share with us in more details how this generation pipeline actually works using diffusion model.
Okay, let's see here. So, thanks, Margaret. What we saw was that diffusion model in action, but that's if you're a computer science person, it's interesting. But let's see how you actually build something with that. So say I had a concept that I wanted to have it generate some art for. With these new models, what I can do, or we'll see it's a pipeline of models, but with these new procedures, all I have to do is put in something like this, a prompt. A cat floating in space wearing a spacesuit. Now, that's kind of cool sounding, but how do we generate that actual picture? Well, they have a model called Clip, which is this high performance, what we call a transformer. You really don't need to know what that does, but it does what we call text encoding. So it takes that sentence, a cat floating in space wearing a spacesuit, and goes through and picks out the appropriate concepts that it can build a picture out of. So a cat, let's see, floating in space, yeah, that could be a picture. Wearing a spacesuit, yeah, that could be another picture. So it picks those out. And then it creates what we call a token embedding. Now this token embedding, this is a series of values, like if you will a key, it says, oh, this feature X is a 0.3, and this feature Y is a 0.7 or something like that, and this feature XY is something else. So it's on a trained model that has been trained against a high performance, high fidelity database. Now you and I have contributed to this database. This is all scraped from the web. This is not something somebody built up. These are scraped from the web. So when you went, and I know you guys did it, and created a cat, picture of your cat and put it up there, here's my cat doing something. It took your picture and your caption and used that as part of its training data. And then there were millions of you, and literally billions of you doing something like that. Because the database that this is trained from, this clip model is trained from, contains over 5 billion photo caption pairs. 5 billion. And that's a small one. They're actually training them up to 7 and 9 billion of these images. So people are, with their phones, taking all of these pictures, and they're creating a huge data set that these things can be trained with. And we now have the capability with these models to train at that scale. But we don't take every picture that somebody, of their cat that they took, because a lot of them are, how should we say, ugly. Maybe not ugly, but they're just not high fidelity. But we want a picture that's a very good looking one. So we go through a process where we kind of correlate them and only pick the ones that are the nicest ones and use those to pass on to our model. Okay. So we now know it's going to create a nice looking picture. And if you notice that picture that Margaret showed, those beaches were very, very nice looking. After we have those token embeddings, we have another process that we feed it to, which is that diffusion that Margaret was talking about. Essentially what the diffusion model does is take those token embeddings, in other words, the mathematical version of that prompt that we have there, a cat floating in space, and use it to tell the diffusion model that was trained on all these other images and things like that, hey, this is a description of the picture I want you to create. And using those values, the diffusion model runs in cycles. It runs typically 50 cycles or something through there. About the first 2 or 3, as you saw kind of in that thing that the thing that Margaret showed, it goes from random noise to starting to create pictures. So the remaining cycles are just to make that those pictures better and kind of glue the various pieces together. If you watch that as it was playing, you may have noticed there were palm trees coming out, but then the palm trees spread out and they put more water in the center and things like that. All of that was done as those latter stages worked. Okay, and then once we have an image, well, we create the diffusion process, and once we have a diffusion image, we can also create what we call an image info vector. The image info vector is not the pixels and things like that you would use to draw the image, but it's something that we can pass to a trained model, namely the image decoder, to create the pixels that we use. At the end of the day, it creates a picture like this. This is one I put in to one of those systems. And look, it's very smart. It has kind of put holes in the spacesuit for the cat's paws. Probably should have put gloves on the cat, poor cat. It's got a little porthole for their face that has a piece of glass or something that they can look. It figured out space around it and things like that. And it put like some sort of planet here in an atmosphere so you could get the idea that the cat was floating in space. And all of this came from this prompt over here, a cat floating in space wearing a spacesuit. Pretty amazing, right? And I have zero artistic ability, so I love these things. It's really just amazing at what we're getting. And if you've been on any of the sites, art sites or anything, you'll see that they are creating so many systems to do this. Let's see. And we're going to take a look at one. We're going to take a look at one called DreamStudio. You can see here its goal is to use machine learning to create generative art. And what I'd like to do is maybe if you people could put some comments in there, something you'd like to see, like a description of that cat in a spacesuit. And if you don't, I'll come up with one. But it's better off if you guys can put something in there. And we'll go ahead and generate it. And it's part of the workflow to generate videos and images. So let's see what this looks like. Hopefully somebody will put something in there in the meantime. Hello. Oh, this is not good. I wonder if they're down. Let's see if we can go anyway. Let me just show you how many of these things there are. Art generator, stable diffusion. Well, let's try this one. As you can see, there are a lot of these things. If you go down here, they just go on and on and on for pages. So you can find your favorite one. So let's.
Jerry, you could also use if
Which one?
DreamStudio is not working, you can use DALL-E 2. Like if you search for like OpenAI DALL-E 2.
Yeah. DALL-E-2, DALL-E, right? DALL-E,
Yeah.
is it this one? It's this one, right?
Yeah,
Let's see if I can get the one
OpenAI
at
DALL-E
OpenAI.
2.
Yeah, I'm pretty
that
sure
one,
I think I have an account here.
yeah, because you could just like log in. If you don't have an account, just pick one and then you can go in.
Yeah.
And then they give you 50 points that you can put in some.
I have, that's not me. You know what? You know what it is? I have an account. I think I should have just, sorry guys. So you said I can just get free points on it?
Yeah. Okay, Jerry, I'm gonna share my screen. It's okay.
Okay. You got it?
Let
Okay.
me share my screen, okay?
Okay.
So
Sorry
let me
about
share
that,
my
guys.
screen. No worries. And thank you for so many live demos. They're tough. So
Yeah.
share screen. Okay, I am sharing my screen. I'm Adisha. If you could add me to the stream, that would be great. Yeah, can everybody see my screen? So this is the DreamStudio that Jerry was trying to show you, but it was not working on his browser. So basically, you come to the DreamStudio.ai. You see that it uses some sort of credit. You can put in. I actually put in. This is like what they prompted over here, and let's try it out with a different prompt, right? So I'm gonna just try it live, see if it will dream it for me. And it's running right now. And I put in a simple prompt, a beautiful beach with sunset, and it's a very beautiful picture that got created. So while I'm on this, I'm going to share with you another website, which is this one. Let's see. This is lexica.art. This one, the DreamStudio, is a web interface to allow generating images with diffusion model, right? This lexica.art, it's not for generating, but more for searching. So if I put in a beautiful beach with sunset over here, you'll see all of these beautiful images that have already been created by somebody else using the diffusion model. The nice thing about this website is that if you click on one of these, and you will see the exact prompt that's being used: sunset over wooden cabin on the coast, in the distance sea, oil painting, very detailed and colorful. So a lot of times the key to generating a nice image is actually to be able to have a nice prompt describing exactly what you want to generate, the style of art you want to be generated, or photo you want to be generated. So that's that lexicon. So since I'm sharing my screen anyways, I am going to just share with you my one more thing. That so here's the slide where we're supposed to be on the slide. Is when there are a bunch of these, DreamStudio, they see the DALL-E, OpenAI's DALL-E. This one, you can try it out as well. If you like log in, you can also try to anyway, I'm not logged in at the moment. You can also try that. Anyway, so you can use these web interfaces to generate images. You can do a comparison using the same prompt and the different website just to see how well they're doing, because some might be doing better than the others depending on the same prompt, depending on the service. And these web interfaces typically work by giving you some sort of free points that you can use. But if you want to generate more, you have to probably pay money to buy the points to generate more images, right? What I want to also point out to you, also, there are a lot of open source notebooks out there for you to try it out. Two of these notebooks are Keras. On the keras.io, like if you search for keras.io diffusion, and you will see, like over here, right? There's this notebook going through. Really, you can actually click on viewing collab, and then you can run through the collab to actually generate images, right? I believe this is using a lot of these code. Earlier, Jerry was talking about the text encoder, the diffusion model, and the decoder, etc. I believe all of these are probably written in the Keras computer vision, Keras CV library, right? So you can just use that library, but you can read through how it works and actually change the prompt and generate the images. So, okay, I'm going to stop sharing my screen now, I think.
So, Margaret, I just noticed a couple of questions in here that are kind of directed to you, actually.
Oh, how come I don't see questions? Like
it's in the comments section here. Oh, there's one. They brought it up here.
Oh, okay.
Okay, yeah, and maybe you could answer. I don't know. Can you see that? You can see that, right?
Yes, yes.
Yeah.
I could see that.
I'm curious too. Remember you
I
and I talked about this.
I know that would be one question Jerry was going to ask you anyways, right?
Yeah.
What would it be the future? So I'm gonna just first talk about the kind of the evolution. We started back in 2015. We have Deep Dream, we had style transfer, which is like combining the content and the.
Uh-oh, did we lose Margaret? Boy, we are having a lot of technical difficulties this morning. I think she was, well, hopefully we'll get her back here in a moment. But I think she was going to go into, this has been a process that has gone on for a while of coming up with all these things. So, to get to, I guess, Sherry's question, which I think boiled down to, will there be artists in the future? I think the answer is yes. To me, art generation is a tool. But, oh, Margaret's back, and I'll let her finish answering that.
Yeah,
sorry. You lost your signal for a minute.
Okay. I don't know how much you heard me. What I'm saying is that, yes, with the diffusion model that's able to generate really these high fidelity images, it does pose some sort of threat to the art and design process. I would say in the art and design process, having inspiration is always very important. So being able to generate these images will assist the artists or non-artists in the creative process. But at the same time, I think there's also some sort of backlash or kind of a negative monetization impact for the artists and designers, because like my day job is machine learning, right? I'm an engineer. I do art and design, but I don't rely on as my source of income. But you can imagine the artists and designers, they rely on that, their source of income, and these AI tools could potentially replace some of that work that they do. And I read about how some artists actually kind of boycott the AI model being trained with their artwork, right? And then people just being able to type in the keyword of their art style to generate their artwork. Yeah, hopefully that answered your question.
Yeah. So Margaret, keeping on that theme, do you think there'll be other tools for people like me that have that probably even that couldn't create the correct prompt, shall I say, that will, assist people like me, just in using these tools and things like that?
Yes, absolutely. I believe both commercial tools, like for example, Adobe has a lot of these, Photoshop and all these Adobe created products, right?
Mm-hmm.
And also Google, whether it's commercial or open source product, I believe there will be a lot of tools. Or even you look at Icons 8, where you look at the assets and stuff. I think there will be tools for people who are not artists or
I'll raise my hand to that.
designers as their as their profession, right?
Uh-huh.
There will be tools to help you, even if you don't know the prompt, but to guide you to actually help you to come up with these ideas. To give you an example, Jerry, you and I give talks, right? And a
Mm-hmm.
lot of times when we give talks, we want some nice images, right, as our background image, or we create an event, we want some sort of event poster, right? So I would imagine like Canva, the tools that help people who are not designers to create designs will be able to use these AI tools to help the non-artist and non-designer to generate really good art and designs.
Do you think I think that I worked on the PowerPoint team for about a decade or something like that. One of the things I knew our customers always struggled with was, being able to find the right illustration or the right whatever for the point they were trying to get across. Do you think that we could take something like these generator tools and kind of hook them into there and sort of, figure that out as we go on?
Yes, absolutely. I think I read it somewhere. I think Microsoft already trying to integrate or already integrated the DALL-E 2 into their
Oh,
existing product. Also create a new, I forgot what the name is, like a new tool to help people generating designs.
yeah, yeah, yeah. Okay, that's interesting. Oh, here's a question here. Madusha asked, how autonomous can an on-device processing be? It can be quite autonomous. We were mentioning that one where there's something out in a field or something like that. It can be out there doing its thing, and needing to transmit information, but it can be completely powered by the sun, right, with the solar panel and a little battery. So it can just be doing its thing and what have you not. And maybe if it can't transmit because, let's say it's using the cellular network or something and the network's down, it can just hold on to that data and keep going about its business. And you could see, in a lot of other situations that would be useful, especially if we think of remote countries with a lot of remote areas that don't have perhaps the infrastructures that some countries do. It would be very, very useful to have them be able to autonomously do things. Maybe I mentioned notifying somebody when it sees a bad bug. Maybe it could take some sort of action. I don't know what that would be, put a screen up or something like that, but just sort of do its thing. Or maybe if it detects hail. I come from a farm family. Hail is a really bad thing on farms. I mean, because it just beats on things, right? So your vegetables and things like that get beat up. So you want to maybe, if you could put some sort of sheeting up, they have like sheeting and things like that, put that up automatically, let the machine deal with that. And then you don't have to, as a farmer or a farm manager, go and run around and deal with that. So anyway. Margaret, you want to take this one here?
Yeah, sure. So the question is, Rao asked, what about if we wanted to create instances or do minor edits? Can we take deepfakes from diffusion models and modify them probably with GANs? Okay, so there are a lot of words in there. I would say there are actually a lot of, like I said, diffusion models are popular, but don't forget about GANs. We've done a lot of great work in GAN variants. If you combine the power of GANs and the diffusion model, you can do a lot of great things. Minor edits, yes, definitely. It's not about just generating the pictures from prompt or noise. You can actually upload an image of yours and then make edits. I have to find the website or the paper and share it with you.
Do you think too, Margaret, that people could use these to create, let's say they had an existing image and they wanted to put a nicer background in it or something like
Yes.
that?
Yes. Yeah, absolutely.
Yeah.
It is possible.
Yeah. Yeah, I could see that with like, Photoshopping with layers and things like that, where you could kind of drop that in behind it or something like that.
Mhm.
And that would be kind of neat.
Yeah, I couldn't remember that paper name off the top of my head. There is exactly that paper and actually a website doing that. So it's not just entering the prompt and generate the image. It's actually entering an existing image, like a dog, and you can change the background or what the dog is doing. The dog is standing or running. Yeah, exactly that.
So wait. They'll actually make the dog stand or run or something
Yeah,
like that?
yeah, or a person.
From a static dog? I mean,
Yeah. So you change what the dog is doing, or you change what you're doing, the person is doing, the posture, etc. So it's actually editing instead of pure generating from the noise.
Yeah.
Or the prompt.
Yeah. Well, it's kind of a long way. As a photographer, I remember when National Geographic moved one of the pyramids or something in one of their covers, and people were up in arms about that. It's, we've gone way kind of beyond that, right? So
yeah. I think being able to control, because when you can try to control what you're generating, there's different ways of controlling, right? Using the text is just one way of conditioning, and like going from image to image translation, that's like the condition, and being able to do the fine editing of what you want the person or the dog and the object is doing. It's quite interesting.
Cool. So you can make can you make people look better? I mean, there's always these filters, right? That photographers use. Could you use this technology, do you think, to filter images as we do?
Yeah, I think so. And also, one thing I want to mention is using the diffusion model, it's also possible to generate like 3D images, because the 3D images, one way of visualizing the 3D is multi-view. That's just one way of the data representation. It's multiple views from different angles. So if you can also generate the images from different angles, you can also have a 3D. I forgot where I read it, but recently there was some model. I think it's NVIDIA. Like I read about it yesterday. NVIDIA actually has this tool actually generating a 3D model itself, not just multi-view of these images, but actual 3D model.
From a prompt or from another image, or?
Probably prompt. Let me see. NVIDIA. Let's see. NVIDIA Diffusion 3D. And by the way, I saw that Anita said, I just tried flat art illustration of man on a computer in DreamStudio, and the results were impressive. Oh, yeah. That's great.
You want to share that with the chat?
Yeah, share it with us.
What is flat art? I don't know, Anita. What is flat art?
Flat art is this graphics that they use these days for a lot of websites. So like when you just it's like cartoonish characters with elongated arms and stuff like that.
Oh, yeah.
Images and videos on websites. So yeah, that was I tried one and I was amazed, because when I thought of like PowerPoint presentations and when you're doing presentations and you have some text, I thought of something suggesting like an image or an illustration just to go with whatever text you're creating, and I could just imagine that doing very well on presentation.
Yeah. Well, there is that. I know Margaret and I had the question about the impact of this. A lot of that, people are using like what was that site you mentioned, Margaret, to me? Fiverr or?
Yeah, like where people will go get a freelance artist or designer to create an icon or create some images and posters.
So, I could see it kind of impacting that then too. That whole whatever you want to call it, that type of a gig economy type thing.
Yeah, exactly. The gig economy, the whole industry, I feel like it's going to be very much impacted.
Yeah. Madusha had an interesting question too. How far are we from adding the laws of physics to all of this?
Um,
Don't know.
I mean, regulation is probably going to come in at some point, but it'll be
Yeah.
interesting to see laws of physics and
Yeah.
structural designers. This is very interesting. It's a very interesting take.
Okay.
All right. So far so good. I think we've had an amazing, discussion back and forth on the trends. I would say maybe Margaret, Jerry, like any last words? I really love the Pete Warden's article you referred us to when I said the future of, ML is tiny, right? The future of machine
Yeah.
learning is tiny. So if you guys had any last words you want to share with the audience, I'd like to, Margaret, you want to go first?
Yeah, sure. I just want to say thank you so much for inviting Jerry and I to this show. I really enjoy sharing everything today with everybody. And what I want to say is, yes, like you said, the future of machine learning is tiny. And what I also want to say is, like, everybody can be an artist and a designer.
Jerry?
Well, I appreciate Margaret saying that everybody can be an artist because I have zero artistic talent personally. So maybe there's hope yet, Margaret, and I won't have to bother you when I need to do something. Yeah, and I would agree that I think this drives home the point that machine learning, AI, all these technologies are the future, and people need to be at least have some sort of passing level of understanding of kind of where the boundaries are of all this and how these are being pushed as we move further. And so we're an educated population as we continue on. And also I also want to thank you guys and everybody out there for being here today. It's been a lot of fun.
All right. Well, thank you, Margaret and Jerry. See you around.
Okay, see you guys.